Here's 2016 question 1. Right away, it's appearing to be a Riemann sum tables problem. Okay, we have water that's being pumped into a tank, modeled by this function here, and then we have R of t, which is basically the rate at which water is being removed from the tank. So it's also a rate in, rate out problem. So there's accumulation involved as well as a Riemann sum table. So you're going to see a lot of these hybrids here, okay, especially for your AP exam. Here we go. Estimate R prime of 2. Very easy to do. R prime of 2 is somewhere in between here. So we're going to choose 1, 1190 and 3, 950. Find your slope. You're pretty much done there, okay? 950 minus 1190 over 3 minus 1. Make sure that the order is correct. And you always do y coordinates first, okay? They do say indicate units of measure. Okay, so here we go. 950 and 1190 are measurements of liters per hour. 3 and 1 were measurements of time in terms of hour. So here is your units of measure, liters per hour, or if you want to get fancy, liters per hour squared. Okay, but equals equal, doesn't matter. I would rather you guys write it just like this. Okay, here's part B. Use a left Riemann sum to estimate the total amount of water removed, okay, during the 8 hours. And then they ask you for a second part, but we'll get to that. So left Riemann sum, okay. So I noticed that the distance here is 1. I'm going to use the left endpoint, so that'll be 1 times 1340 plus the next distance is going to be 2 times 1190, the left endpoint, plus 3 times 950 plus 2 times 740. Okay? So if you want to get really good with your Riemann sums, I would practice all the types of area approximations. So like here they did left Riemann sum. I would try to do what it looks like if it was a right Riemann sum or trapezoidal. Okay, that way you can get really good at it. Okay, so here they ask you a follow-up question. Is this an overestimate or underestimate? Okay, so remember, with left and right Riemann sums, it's determined by the direction of the graph. Okay, so they have to indicate somewhere the direction of the graph, and if you skim through it, you'll see the word decreasing. So personally here, I can never remember it, so I always draw it out. What you do is you draw a decreasing function, anything that's going down. Okay? Doesn't matter if it's concave up or down for left and right Riemann sum, okay? So you draw a decreasing function, and then you draw left Riemann sums, so rectangles where the left endpoint is touching the curve. Okay? So based on this picture, I could tell that this will be an overestimate, but again, a picture is not enough. So you guys have to mention 3 things: that it's an overestimate for a left Riemann sum that is strictly decreasing. You cannot get that point if you don't mention all 3, okay? So just keep that in mind. Cool. Okay, here's part C. Use your answer from part B to find an estimate of the total amount of water in the tank at the end of 8 hours. Okay, so back up to here. We could leave it like that, equal is equal, but part C does require you to use your answer there. So what I recommend you guys doing is when you get to part C, then compute. You do have a calculator. Compute this in part C. Okay? So here's what we're going to do. Don't write your answer 8,050 in part B. Okay? Leave that for part C. So 8,050 is going to represent the amount of water that's being removed over the course of 8 hours, okay? So if we remove it, we know we're going to have to subtract it, okay, which is where this comes from. But we do have to consider So this is what went out. We do have to consider what goes in, and we do have to consider what we start with, because we want to find the total amount of water. Okay? The in and out is just the accumulation, but if you want to find the total amount of water at a particular moment, you got to consider, well, at time 0, how much did I start with? So they do tell you in the text, at t equals 0, there are 50,000 liters of water in the tank. This setup is very common. Your starting value plus the integrals of your ins and your outs. Okay? Now, how you actually integrate W of t, remember, W of t was given as an equation. So you do have to type this in as y1 and then integrate that, okay? But basically, you get this. Okay? I believe they do say to the nearest liter, so you do have to round it to the nearest whole number, okay? So make sure that you're following the directions there. They don't ask for units, so you really don't need that, okay? Here's the last one. From 0 to 8, is there a time t when the rate at which the water is being pumped into the tank is the same as the rate at which the water is being removed? So, in short, they're asking you this. Is there a moment where W of t is the same as R of t? That's what they're asking you guys. Is W of t equal R of t at any moment? Okay? So, you can do two things. Okay? So, you can graph these two, but the thing is, you don't have enough information for that. Okay? So, if you have W of t, but you don't have R of t in terms of the equation. So, what you do is, you check at specific values. Okay? So, let's say you check at 0, and people tend to like to choose the endpoints here. I know that R of 0 is 1340. Okay? And I know that at R of 8, I'm removing 700. Okay? Liters per hour. So here's what you do. You check the difference. Okay? So what I mean by that is W of 0 is pretty much Y1 of 0 on your calculator, okay? Minus R of 0 is really just, I believe it was 1340. Okay? When you plug this into your calculator, it comes out to something positive, okay? When you plug in 8 for Y1, and you subtract it with R of 8, which was 700, you get something negative. Something positive to something negative. Okay, something positive to something negative. If you're trying to find out where W of t is equal to R of t, that's pretty much saying, well, what would happen if I were to subtract these two same equations? What would it equal to? It would come out to 0, right? So we showed that the difference in the two rates came out positive and then negative. So we know there has to be some time in between 0 and 8 where it'll hit 0 exactly. Okay, and that's according to the intermediate value theorem. Again, not too obvious. It takes a lot of practice for that. But I do anticipate them showing up on your AP exam. So make sure that you guys put it in practice, okay?